The next question on your sheet shows what is standard form, okay, of an equation. And remember, we've talked about things like slope-intercept form. We've talked about solving for a variable, getting y or x by itself and substituting. And we briefly talked about standard form at the beginning of the graphing chapters. Anybody remember what standard form looked like? Standards form when you have the x, then plus or minus the y, then the equal sign, and then you have the number without the variable on the other side of the equal sign. So in this equation, A stands for the number in front of x, B stands for the number in front of y, we call it coefficient, right? And C stands for the number by itself, the constant. So whenever we solve elimination problems, we want them in this form. We want the x, then plus or minus the y, then the equals, then the number without the variable. Okay, this is called standard form. So then we kind of got three different ways now. Graphing, what form do we want graphing problems in? Slope-intercept. And then substitution, what do we want to be true about one of the substitution equations?
Y or x.
Yeah, y or x alone. Y or x is solved for, right? And then elimination, we want them to be in this form, in what we call standard form. Ax plus by equals c. Okay, the x, then the y, then the number without the variable. So that first one you have looks like this. It says x plus y equals 5, and 3x minus y equals 7. Are those two in standard form? I'd say yes, right? Because it goes the x, then the y, then the equals, and the number without the variable. Then the x, then the y, then the equals, and the number without the variable. Okay, these are in standard form. So this is elimination. Now, we can either add these two equations together, or we can subtract them. Okay? And we want to do whichever one was going to eliminate one of the variables. It's going to make one of the variables go away. Okay? So for example, if I were to add these two equations, well, 5 plus 7 is going to be 12. I'll just draw down the equal sign there. Right? 1y plus negative 1y is going to give you 0, right? That's eliminated. It's 0. So we're not going to write that. And then 1x plus 3x is 4x. So now I'm left with this equation. And this is very simple to solve. What are you going to do to solve for x here? Yeah, just divide both sides by 4. So you get x is 3. So now I know what x equals. The solution for x. Then I want to find out what's the solution for y. So you can take this x and substitute it into either one of these problems. I'm going to pick the top one just because it looks a little easier maybe. If I put in x there, that's going to give me 3 plus y equals 5. Of course, we know y would have to be 2 there, but if we had to solve it algebraically, we would subtract 3 from both sides because it's a positive 3, and y would be 2, and there would be my solution. X is 3, y is 2. And remember, on all these problems, you can always check your answer by plugging it back in to make sure both of them are true. 3 plus 2 is 5, that works. That'd be 9 minus 2, which is 7, so that'd work. Right? So you can always check your answer on graphing, substitution, elimination problems. Solving systems. So we're going to either add or subtract whichever one's going to eliminate one of the variables, because then it becomes really easy to solve, and then we just substitute back in. That makes sense? In this equation, or two equations I guess, what operation is going to, well first of all, there's no way you're going to be able to eliminate these right now, right? 1 and negative 2, whether you add or subtract, there's going to be something there, right? But these 4x's, these are both positive 4x. Should you subtract these or add these to get them over? So I'd subtract them, right? When you subtract those, that's going to eliminate the x's. So then you just subtract everything else. 7 minus negative 2, positive 9, right? 7 plus 2. Drop down the equal sign. 1y minus negative 2y. What's that going to give me?
3.
Good. 3y because it becomes plus. And 4x minus 4x is 0. That's eliminated. It's gone. Right? So then to solve for x here, I'll divide both sides by 3. And that gives me y equals 3. I now know what y is, so I can find out what x is by plugging that back into either equation. Okay? I'm going to pick this top one here just so I don't have to deal with a minus sign or a negative sign. So if I plug y back in, that gives me 4x plus 3 equals 7. And I want to solve that equation for x. Undo the addition first. Subtract from both sides. 4x equals 4. Divide both sides by 4. And x is 1. So my solution is x is 1, y is 3. Because if you were to graph these, that's where they'd cross. 1, 3, right? You could have also done it by substitution. This would have been the variable you probably got by itself. Right? You subtracted 4x from both sides and then substituted for y. Or if you graphed them, you get that in slope-intercept form. You get that in slope-intercept form. That's where they intersect. Elimination is the same thing. It's just another method to helping us solve when we have two equations and two variables. Any questions with those two so far? So what operation are you going to do to eliminate here? Subtract or add? Subtract, right? That's going to eliminate the x's. 3 minus 6 is negative 3. Drop down the equal sign. 1y minus 4y is negative 3y. And 3x minus 3x is 0. It's eliminated. Solve for y here. Divide both sides by negative 3. Negative divided by negative is positive. So now I have my y. Y is 1. I want to solve for x, so I can either plug in y here and solve for x, or plug in y here. It doesn't matter. Let's just say I pick the top one. I'm going to plug in y right there. 3x plus 1 equals 3. I need to solve that for x. Undo the addition first. Give me 3x equals 2. And divide both sides by 3. And x is 2/3. In this case, I got a fractional answer. That happens. Right? Answers aren't always integers. I just did 2 divided by 3, couldn't divide it, so I left it as 2/3. So that's the only solution to this problem. X is 2/3, y is 1. Makes both of these things true. Anything else would not make both of them true. Kind of getting the hang of this now? It's really just longhand addition and subtraction and solving equations. All right, I'll give you a few minutes to try this one, and we'll check it together. So looking at this one, we want to decide whether to add or subtract. If you're ever unsure, you could just try both, right, and see if one's going to eliminate. I'm looking at the x's, 2x and 1x, and right now there's no way I can eliminate those as they sit. Right? I can add them, it'll be 3x, I can subtract them, it'll be 1x. So I'm looking at the y's here. I have a negative 3y and a positive 3y. If I subtracted them, negative 3 minus 3 more would be negative 6y. So that wouldn't eliminate. But if I add them, negative 3y plus 3y is going to be 0 and they'll be gone. So negative 2 plus 17, if you're in debt $2, you add 17, you're now up 15. That's eliminated, becomes 0, and 2x plus 1x is 3x. We want to solve that equation for x, divide both sides by 3, and x is 5. Then we can pick either one of these equations to plug x back into. I'm going to pick this one because I don't have to deal with a minus sign or negative. But you would get the same answer either way. So if you plug in x there, you get 5 plus 3y equals 17. Move over the positive 5 to both sides by subtracting it. You get 3y equals 12. And undo the multiplication by 3. And you get y is 4. We get that answer? Yeah. All right, good. Got it. Again, if you wanted to, you can always check your answers, right? Plug in x is 5, that's 10. Minus 12 is negative 2. That'd be 5 plus 12, because that's a 4, is 17, and both of them are true. If you graphed them, that's where they'd cross. You could have used elimination. You would have probably got that variable by itself and still got the same thing. All right, the last one with variables here given to us looks like this. Now, we're going to solve this one by elimination, but what method would be pretty easy to use here as it sits right now? Substitution would be probably pretty easy here, right? Because you already have y by itself, so you could plug that in for y right here and start solving by substitution, right? Substitution would be a good way to do this problem. And really, graphing wouldn't be that bad, because this is already in slope-intercept form. You would just have to move this to the other side by subtracting it, and you could graph them. Okay, but we're going to solve it by elimination. Now, what's the difference in this problem and the previous elimination problem?
It's not standard.
It's not standard form, right? This one has the x and the y, then the equals and the numbers, but this one is not. Okay? It's not in standard form. We always want the number without the variable on one side of the equal sign, so I'd like to move this to the other side. And since it's a minus 2x, we can just add 2x to both sides, right? Now I'm going to put it out here in front, and since that's a positive y, it means that'll be 2x plus y. So I'm going to rewrite what I have left here. It'll be 2x plus y equals 7 when I rearrange it. All I did was I rearranged that equation to put it in standard form, just like we've done with slope-intercept form, and just like we've done when we solve for variables. So I'm going to go ahead and get rid of this one here. So looking at these, I want to decide, am I going to add or subtract? So there's no way I can eliminate the x's as they are right now. One's a 2 and one's a 4, but I have a 1y and a 1y. So you're obviously going to subtract. Right, good. 7 minus 5 is 2. Drop down the equal sign. 1 minus 1 is 0. It's eliminated. 2x minus 4x is negative 2x. And solve for x. You get negative 1. Positive divided by negative is negative. We need to solve for y now. You can plug that back into either one. Let's just say I pick the top one. It's going to be 2 times negative 1 plus y equals 7. It's negative 2. We're going to get y by itself, so we add 2 to both sides, and y is 9. And there's my solution. X is negative 1, y is 9. And you can always go back and check your answer. Questions with that? So when it's already in standard form and you can eliminate right off the bat, elimination goes pretty quick. Sometimes you got to rearrange the equation and put it in standard form. The last question says find two numbers whose sum is 18. Sum means what again? Addition, right? And whose difference is 22, and difference means subtract. So you could guess and check on this problem, but it might take forever, right? You want two numbers to add to 18, 10 and 8, but those don't subtract, give 22. 9 and 9, 17 and 1, and you could just keep going back and forth, right? And just be guessing and checking all day. But you can also set up two equations to solve this one by system of equations. If you call the two numbers x and y, the first one says their sum is 18, so you can write x plus y equals 18, right? That represents the first equation. The sum of the two numbers is 18. What would the other equation look like? Yeah, their difference is, that means equals 22. So now we want the x and y that make both of these true, just like the previous problems. They're both already in standard form. Now, this is a rare case that it doesn't matter if you add or subtract. Because if you add, the y's are going to be eliminated. If you subtract, the x's are going to be eliminated, right? So you can actually do either one here. When given the choice, I would add. 22 plus 18 is 40. 1x plus 1x is 2x, because 1y plus negative 1y went away. Undo that multiplication by 2. And I get x is 20. Now you need to find out what the other one is. So take it and plug it back into one of them. I'll pick the top one. 20 plus y equals 18. To get y by itself, you subtract the positive 20. And y equals negative 2. And there's my two solutions, right? You add those two numbers, it's 18. You subtract those two numbers, 20 minus negative 2 becomes plus. Subtract those two numbers, it's 22. So you can use a system of equations to represent that situation.